This is the final video in a set of videos that have been trying to demonstrate the gear ratio equations of the gear ratio over 1 is equal to the number of teeth out divided by the number of teeth in, the diameter out divided by the diameter in, the speed, that's omega n, divided by the speed of the out gear measured in RPMs. And now finally we're looking at torque out divided by torque in. Torque is a measurement of how much force the gear is turning with. So in the example up here it's changed again, and in this example we have the out gear this time that is giving us a final torque of 20 foot-pounds. So in order to be able to figure out this equation, we're free to use any of the data that we've used in the past 3 or 4 lessons. So in this case, I think what we'll do is we're going to use the data that we've got right here. We just calculated the speed at which So I'll use the 30 RPMs divided by 20 RPMs, the speeds, to calculate the rest of the torque equation. So the rest of the torque equation is simply 30 RPMs divided by 20 RPMs is equal to 20 foot-pounds, since it's in the out gear. It has 20 foot-pounds on the out gear, divided by the in gear. So now we've got to calculate 30 times T of n is equal to 40 RPMs times 20 foot-pounds. So let's see what we get out of this equation. Let me take this equation right here, group it together. Let me move it out of the way. We'll put it way over here so I can put some more stuff next to it. By multiplying 30 RPMs times T of n, we get 30 RPMs times T of n here equals 20 RPMs times 20 foot-pounds is equal to 400 foot-pounds times RPM here. It's important to keep your units going. Doesn't matter which one you use here. You're going to have to either use RPMs, inches, teeth, or this one does not have a, since it's a gear ratio, it does not have a unit. But it's important to keep your units the same and follow through the math. So the next step in the equation is to divide both sides of the equal by 30 RPMs, because we've got to find Tn by itself. So we divide 30 RPMs out of this side, this factors this out, and then we have to do the same thing on the other side of the equation. So it's 30 RPMs divided into 400 foot-pounds times RPMs. Well, the RPMs factors out, and you end up with an answer of 13.3 foot-pounds. It's 13.3 repeating foot-pounds. The reason we end up with foot-pounds is because the RPMs on both sides of the equal mark factor each other out. So we know that torque is a unit of force, and force is a measurement in foot-pounds. So torque of N is equal to 13.33 foot-pounds is the correct answer for the problem. I hope these have helped you, and I hope you can see the relationship between all of the different types of formulas and methods that we're finding to calculate our gear ratio problems. In the future, you're going to have activities and assignments in the class that require you to use this knowledge to figure out mechanical advantages in things like mousetrap cars and complex vehicles or machines and those kinds of things. If you have any other questions, please watch the videos again, review your engineer's notebook, or come up and ask me questions. So thanks for watching again.